Hello, today we're going to talk about zeros of polynomial functions. Now remember, the term zeros means x-intercepts. So we're looking at x-intercepts for any graph. One reminder from just a couple lessons ago is this, that whatever your highest power is, highest power determine possible zeros. Okay, so highest power determine possible zeros. Okay, so if my power was a 3, we'd have at most 3 zeros. If my power is a 5, we'd have at most 5 zeros. So keep that in mind. Now, this is telling us how we can find our zeros. So the possible zeros are the locations of those zeros. What you do is you take the factors of your last term, a sub 0, and you divide it by the factors of a sub n. Okay, that's how you're going to get that. So they call these P and Q. The top they call P, and the bottom they call Q. All right, so this is our P here. This is our Q right there. So let's look at an example so you can see this. This is actually quite simple. So there's 3 possible zeros. Now, why is there 3 possible zeros? Because the greatest power is 3. And the possible rational zeros, this is the actual location, are going to come from P divided by Q. Now, so we don't get confused, I'll put P divided by Q, and I'll do it in these colors. So this is my Q right here, which needs to be a 1, and this is my P here, which is 4. So the factors of 4 are, and you do plus or minus on these, so we'd have 1, 2, and 4. Those are the numbers that could divide into 4. Now all this will be divided by the factors of 1. So obviously 1 doesn't change any of these, so you could actually just simplify this and say my factors are plus or minus 1, 2, and 4. They could be positive or negative 1, positive or minus 2, positive or negative 4. So if you wanted to find which ones, by the way, that's the answer here when it says list all the possible, that's the possible rational zeros. Now, if you needed to find which one of those are true, you could use something like synthetic division. Remember how we wrote down the coefficients? So I have 1, negative 3, negative 2, and 4. And let's just say we wanted to see if positive 1 was a possible rational zero. Well, we do synthetic division here. And so you pull down a 1. 1 times 1 is 1. You add these two, you get negative 2. You multiply those, you get negative 2, which gives us negative 4. Negative 4 times 1 is negative 4. Hey, this is a factor because 0 is my remainder. And if that's a remainder, I didn't spell it remain. Oh, yeah, I did. There it is. Remainder. That means it must be a factor. It's a factor because my remainder is 0, okay? So now, if you wanted to, let's remember this start off as x cubed here. That means this one is x squared. You could just use x method to find other factors. Okay, so that's my x squared term, that's my x. So I could say factors of a times c that add up to b, which in this case, my values for a is 1, c is 4, so we'd have 1 times negative 4, and then we have negative 2 here. What are factors of negative 4 that add to negative 2? Well, there's no rational factors. So that means the only rational factor is positive 1 that we found right there. 1 is only rational factor. And that could be our other answer. Okay, now I want to do another problem with you. And so hopefully we go a little bit faster here. Now I want to ask you, how many possible zeros could there be? Answer 3. There's 3 possible zeros. And so what are those rational zeros? Possible rational zeros, let me write that. Okay, which would be P divided by Q. Remember, this is P, This is q. Okay? So you'd have plus or minus. And what are the factors of -1? Well, just 1. And then what are the factors of 1? 1. That means we can only have plus or minus 1 when you simplify. So again, if I wanted to do synthetic division, I'd have 1 there. I don't have any x squared, so I'm going to put 0x² there, 0 for that spot, a -2, and a -1. We're going to try +1 again first, because I think the positives are easier to work with. And let's go down. So we have 1 times 1, which is 1. That adds up to 1. Multiply, we get 1 again, -1. -1, we get -2, which is a remainder, so not a factor. So +1 is out. Let's try again. This time, let's try with -1. So this time, we'll try -1, and all this stays the same. Because it wasn't a factor, I can't simplify. All right, so I pull down my 1 here. And I get -1, -1, -1 times -1 is +1, which is -1, +1 again, which is 0. That means this is a factor. So this time, -1 is my only factor. So these were my possible factors. -1 is the only rational factor. So these are the only two that were possible, +1 and -1. But as it turns out, -1 is the only rational factor. We could try to factor this if we wanted to, but again, we've already eliminated all the options. So even if you tried, you wouldn't be able to come up with factors of -1 that add up to -1. Can't do it. There's none here. So because it's going to be +1, -1 are the only options, and those don't add up. So that's how you do this. Now you try this problem.